me if I didn't record it down. I can review. Okay, which situation will not happen based on Newton's first law of motion? The key is not. You are looking for not, right? The wrong answer. A force is required to change the state of motion of an object, correct? That's the first law.
Yeah.
When a push is removed from a moving object, the object stops moving. Wrong, right? When you
Isn't
push
it true,
object,
Archer?
no, you push
Isn't
it,
it true?
you are giving it a force, so it's moving. So when it's moving, you remove the force, it continues with constant velocity.
Oh yeah, the net force will be 0, right?
The force becomes 0, but it's moving, so it continues with constant velocity. When an object is at rest, the net force acting on the object is equal to 0. That's right.
Correct.
When an object moves with a constant velocity, the net force acting on the object is equal to 0. That's right. Net force is the resultant force. Okay, next question.
Oh, Archer, 1 minute now. Okay, the next question. Number 4.
Number 4. Linear momentum and conservation. The particle P moves with a constant velocity and collide head-on with a particle Q, which is stationary. After the collision, both particles move with the same velocity. It means they stick together. Which statement is true about the collision? Okay, P move with constant velocity, collide head-on with particle Q. Q is stationary. After collision, both move together with the same velocity. Okay, so straight away we know that it's an inelastic collision. The increase in momentum of particle Q is equal to the decrease in momentum of particle P. Right? So you should be able to write this equation down. Oh, I've done something wrong. Oh, momentum. Sorry. Let me just correct the mistake. Okay, first, you are told increase the momentum of Q is equal to decrease the momentum of P. Yeah, one must increase, one must decrease, so that the momentum stays the same. Total momentum stays the same as the initial momentum. The increase in kinetic energy of particle Q is equal to a decrease in kinetic energy of particle P. Is it right or wrong?
Sorry, Chal.
We say the increase in kinetic energy of particle Q is equal to a decrease in kinetic energy of particle P, correct or not?
No.
No, unless it's elastic collision. Right? This one is straight away we know it's inelastic collision. They didn't tell us it's elastic collision. We know it's inelastic. So it cannot be true. False. Total kinetic energy after collision of particle P and Q is bigger than the total kinetic energy of before collision. Is that true or false? Yep. Should be able to discuss with me now.
The total energy bigger than the what's that total kinetic? No, it has to be conserved, what?
Huh? What do you mean? This is not,
No,
remember, it is not elastic collision.
oh yeah, this is inelastic. Cannot
Ah,
large.
straight away we know in elastic collision already. So is it right or wrong?
Wrong, wrong.
It should be less, not more. Because in a collision, there's going to be sound, there's going to sometimes be light, and there's going to be work done in deforming the two car colliding. The car will be damaged. So there's going to be work done. Right? So the total kinetic energy will usually decrease. It won't increase unless it's an explosion.
Hmm.
The force acted by Q on particle P is less than the force acted by P on particle. Right? It cannot be less. Right? This is the third law. Force. The force should be equal and opposite. Q hit P, P hit Q back with the same force, but equal magnitude but opposite direction. Okay, so the answer is A. Okay with that?
Where answer? Okay.
Now, next question.
C.
Number what?
Number five. Number five.
Number 5. Sphere A and sphere B collide head-on elastically. This is elastic. Which statement is true of the collision? The loss of momentum of sphere A is equal to the loss of momentum of sphere B. Right or wrong? Yep. Conservation of momentum.
No, no. If loss of momentum A means, then should be equal to gain of momentum.
False. When the sphere loses momentum, the other gain momentum as momentum is conserved.
Conservation of momentum, no?
Momentum. Okay with that? The loss of momentum by sphere A is equal to the loss of momentum in sphere B. Cannot lose. One lose, the other must gain. That's why it's conserved. Momentum doesn't disappear. After the collision, momentum of sphere A is equal to momentum of sphere B. Yep.
No, one of it has to lose, one of it has to gain.
False.
Because elastic, one will stop, one will move. What?
It has to be total momentum is conserved, not momentum of A and momentum B alone only. What must gain, what must lose, correct? It's not the momentum of A equals to B. It's the total momentum of A and B before collision equals to total momentum of A and B after collision. The loss of kinetic energy by sphere A is equals to the gain in kinetic energy by sphere B. Is it right or wrong?
Correct.
Why is correct?
Same actually, because I mean it's what do you call that? I mean because AB, like AB is moving, A suddenly happens to bump to B, A will stop and then B will move because this elastic collision, so it's something similar to momentum lah.
Okay. Remember, elastic collision, kinetic energy is conserved. That means if one lose, the other must gain equal amount. That's what it means by conserve. It cannot be smaller or greater. After collision,
Yeah, I mean they say like energy cannot be what is that added or I mean it's
this is not
like the
energy.
same.
This is not total energy. This is kinetic energy. Key is
Oh
elastic
yeah.
collision. Right? Kinetic energy is
Okay.
conserved. That means it stays constant, cannot be lost or gained. After collision, the kinetic energy of sphere A is equal to kinetic energy of sphere B. Cannot be. Right? It's the total kinetic energy of sphere A and B before equals to total kinetic energy of A and B after. Right? Momentum is conserved. Okay? Not A only, not kinetic energy of A equals kinetic energy of B. It's the total kinetic energy of A and B before equals to total kinetic energy of A and B after collision. Okay, any more question to ask?
Yeah, 6.
Okay, the Earth Moon system is shown in diagram below. Which statement is true about the center or mass of the Earth Moon system? I'll give the mass for you. This is a small mass of the moon, big mass, big M from Earth, and then distance is B from the center of mass. C is the center of mass. Okay, center of mass is nearer to Earth. Is that right or wrong?
Correct.
Why is it correct?
Um, I mean we use that formula lah, the M divide M plus M times R lah, then we can differentiate. But
Yep. So we are just using M times A equals to M times B. If the center of mass there. So if the Earth is heavier, so B is going to be smaller. That means center of mass will be nearer the Earth. Okay, that's how we argue it out. Okay, next question.
wait, 1 minute. Because the Earth is even more heavier, that's why like the what's that? It's nearer lah. But it's based on the
We are
formula
just
lah.
using this formula. This one is big. This one is small because this value is constant.
Yeah. Or that means something like directly proportionate lah.
This is inversely proportional.
Eh? No, because MA equals to MB, then M is direct more than M. Oh yeah, inverse.
Inversely proportional.
Yeah, because the fact is the mass is even more higher of Earth than Moon. That's why, right?
Yeah, Earth has a greater mass that you must know. Okay, next question.
Okay. 7.
Coin is placed on top of a block as shown in diagram below. If the coefficient of static friction between the coin and the
Mu.
block is 0.3, what is the maximum acceleration of the block so that the coin does not slip? Okay, first thing you need to know for friction, right? Mu times the normal reaction. So in this case, mu is your normal reaction equals to your weight for the coin. Then you are given mu is 0.3 coefficient of friction.
Yeah.
And then
Oh, you know what I did straight away?
yeah,
Mu mg equals to ma.
mu mg equals to fa. So how do you get that?
No, can what? It makes sense. Mu because mu and then mg we mu mg equals to ma. We can what cancel out the mass what? Then mu 0.30.
You must have a
Then
proper reasoning, not simply mu mg equals to ma. How do you How do you get that straight away?
But this one I got from the note lah. Check and straight away do actually.
By right, you should do step by step lah. Okay, I'm not sure whether it's right or wrong. Let's see. That's how I would do it. All right, mass of the coin. So for acceleration of the coin, right, friction equals to force on the coin. Okay, there's a friction force on the coin. There's a force on the coin forward by this block. So friction, you got that? That's your friction. You happen to be right lah. Happen to be right. Equals to MA. So M and M cancel off. Mu is 0.3, G is 9.81. Multiply out, you get the right answer, correct? You are right. Okay. Okay, next question.
Yeah. Number 8.
A stone with a mass of 3, 4, 5 kilogram.
Oh, 8, 9 I didn't do lah.
Oh. Placed on adjustable plane, the worker has raised one end of the plane to move the stone down the plane. The angle of inclination of the plane is 30 degrees when the stone starts to move. What is the coefficient of static friction between the stone and the surface of the inclined plane? You can remember formula, go ahead. If not, go to the basic there. This is your mg. This is 30 degrees of theta. The angle must be theta. So replace this one with your mg cos theta, mg sin theta, that's all. And then there's your normal reaction. Now, normal reaction is balanced by this one, mg cos theta. Okay, so your friction is equals to this one, no? Coefficient of friction, mu n equals to mg sin theta. So replacing mg with the component, that's what we do here. For sliding, the force downwards there equals to the friction, mu mg. Then you can put your n, no?
You can cancel the mg lah.
Your n equals to mg cos theta, cos 30, mg cos 30. Then you can just can cancel the mg, no? Take the cos theta across there, become tangent theta, no? Right? You can memorize formula, go ahead. As I said, there are so many formulas to memorize. That's why I don't encourage memorize. I derive it, no? You can go ahead.
No, but the teacher says very hard for you to understand the derivation. Means just swallow it. That means just memorize it, like he said.
No, to me, I will say it's better to understand the principle.
No, sometimes we like super complicated, mean then no use with it.
If it's super complicated, so many formulas to memorize, how to memorize everything. Okay, next question.
Okay. Yeah, can go next question, teacher.
Okay. An object of mass 0.35 kilogram is pulled from rest along a rough surface of a table by a horizontal force of 5 Newton.
So that means more. That means there is no what is that coefficient of static friction lah?
No, it's a rough surface, so there's coefficient of static friction. This one is moving, so it's kinetic friction.
Yeah.
If the
Rough
velocity
means
object is
we'll
4,
have
after you have moved 1.2
mm,
meter, what is the coefficient of friction between the object and the surface of table? So roughly that's your table, that's your weight, that's your static friction, that's your force. Right? So you have to calculate your force. Yeah, it's a rough table, means there's friction. So calculate your acceleration. No? You are given a distance, you are given the final velocity, and then you are told you start from rest. Right? Start from rest here, pull from rest. So put in your formula to calculate your acceleration. Can take your u across, you get b squared minus u squared, and take your 2a down, 2s down, got 2s. Right? There's your 4 for final. Initial is 0, 2, distance is 1.2, and calculate out. So we are calculating the acceleration, so we can calculate this force. And we use Newton's second law. Resultant force is ma. So how do you get resultant force? That resultant force minus your frictional force goes to ma. So we are told the horizontal force is 5. Put in 5. Your F is what we want to find. So you must remember we have to replace it by mu mg. And then your mass, we are going to change in 10 minutes time. Your mass, that's your mass.
all right.
And that's your acceleration. Put in there. Then you multiply this up. Right? Multiply this value up and take it to the left. That's what we get. And then we divide by mg. That's your m. That's your g. Then you calculate out. Okay.
Okay.
Next question. You need to try your question
Um,
already. No more time already. No much time already. I think 2 more weeks only.
yeah.
You have to speed it up. No, you're not going to finish your revision.
Yeah, so that means I do as much question as I can lah.
Yeah. Then you can have a
Okay.
feel of more confident yourself if you can do it.
Sure, but if I really don't understand the question, I can refer answer, right?
Yeah. You don't know, then can look at the answer.
I mean, no point staring at it and then not
No
doing
point,
it,
no
lah,
point. If
right?
we cannot, after working for it for a while, then don't know that's the purpose of giving the answer. Then you can spend the
Mm.
time here asking things that you don't understand.
Okay. So that means
Okay,
I
waste
like
too
do
much time.
first, then ask lah, one shot lah.
Anything you don't understand can ask. More profitable.
Okay, section C.
Section C.
Sure, you know what my school doing, sure, they only testing like objective lah, sure, they didn't even test structure and essay at all.
I see.
Because they say like this, objective is even more harder. When you do objective means it's easier to do subjective, they said.
By right, they should teach you how to answer question, not do objective. But anyway, different teacher have different method. Okay, the whole question is it? Question C. Define
Yeah.
impulse. Memory work, this one. Impulse is a product of force and duration of the force acting.
Yeah, I mean, it's the product of force and the time lah.
Yeah. And you impulse is Ft. So your force is your mass times acceleration. Acceleration is V minus U over T. That's your Newton's second law. And then you cancel the T. You get mv minus mu. That's how you derive. A piece of plasticine and a ball bearing of the same mass are dropped vertically downwards from the same height onto the hard metal surface. Explain whether the plasticine or the ball bearing which would exert a larger average force on the surface. You'd like to comment on that?
No, sir.
Anything? Anyone you want to answer? Try to answer.
Okay, they say there's same mass, they work vertically downwards, same height, and then which one would wait, isn't it wait, plasticine and ball bearing? Ball bearing is more heavier lah, right? No. They say same mass. So
Same
same mass downward. In terms of force, right? Actually, both of them will be the same lah.
We should have a larger volume.
Larger volume, the ball bearing lah.
Huh? How do you decide that?
No volume, right?
Which has a larger density? Yeah, which one has a larger density?
P equals to M over V. They said the M is same mass already for both. Volume, but we don't know what the volume is.
You can know, which has a greater density, you must know.
Wait, everything they say same is the mass and the height.
Yeah.
Now they're asking which one average force. So
You must know the volume, which one has a larger volume? Which one has a larger density? Before I can answer this question, which has a larger density?
the plasticine, right?
No, plasticine is lighter. Ball bearing is
Yeah, I said ball
heavier.
bearing just now.
Ball bearing is heavier. Density of ball bearing is larger than density of plasticine. The volume of plasticine is greater than volume of ball bearing. So when you drop them, there's going to be air resistant. Right? For ball bearing is smaller, so air resistance is negligible. Whereas plasticine, the volume is bigger, so it's more significant. Okay, since the height is short, air resistance is negligible. Both ball will reach the surface at the same time. The impact with the surface is shorter for the ball bearing, so the rate of change in momentum and thus the force on the ball is larger. Sorry, if they are both the same height, short distance, then air resistance is negligible. If it's greater height, then it's different thing. If it's large height, then the air resistance will come in. Now, in this case, we don't need to worry about air resistance. But what is happening? The ball bearing, right? The impact time with the surface is shorter for ball bearing. Right? So you are using what you have here. Shorter time for ball bearing. So the rate of change in momentum and thus the force on the ball is larger. Applying Newton's third law, the force on the surface is equal but opposite. Okay. Yep. Plasticine is softer, so it takes a longer time as it hit the surface. So the change in momentum, rate of change in momentum is also smaller, so the force is also smaller on the surface. Okay with that?
Yeah, okay.
Right? The key is one is softer, one is harder. Harder one, the impact is shorter. Softer one, it can deform more, so it takes longer time. So the force is going to be smaller on the plasticine.
Wait, harder one, the impact is less lah.
Harder one, we are looking at this time there, that time there. Forget about this D, we are looking at this force there. So if that time is very small, then the force is very large. Whereas if that time of impact is very small, very large, then the force is very small. Okay, let's happen to plasticine. The force is small. Okay. If okay, take 5 minutes break.
Wait,
Here the key
yeah,
is short height.
force.
Short height, so hair resistance doesn't come in.
Keyword is what, sir?
The
Short
height is
height.
short, air resistance is negligible.
Okay.
So if you feel the height is large, then you have to consider the height. Then air resistance is not negligible. Yeah, consider short height. Then air resistance is negligible.
Okay.
Not clear from the question. What they really want. Okay.
No wonder it's hard to score in STPM lah.
STPM a bit not clear lah. So it's up to the examiner to decide what to mark right or wrong.
No, the examiner super strict lah, because this week also he did they did technique menjawab for chemistry, you know, the significant figure they very pantang one.
Okay, we have to take 5 minutes break already. We start a new Zoom soon. Take a break.